Good morning, good afternoon, or good evening. Today we're going to be talking about graphing piecewise functions. When I write this function, I'm going to write f of x equals, and then I have this set here. I'm going to write two or more functions. Notice how these functions have domain restrictions. So this first function, x minus 2, I'm going to make its own t-table. It is only valid when x is less than 1. So I'm only going to choose x values for my t-table that are less than 1. My other function, x squared minus 4, is only valid when x is greater than or equal to 1. So I'm only going to choose x values that are greater than or equal to 1. The first point that I'm going to put on my t-table is 1. And since those values are all less than 1, I'm going to put 1 at the bottom of my t-table, and then I'm going to choose values smaller than that. I'm also going to put an open circle next to it because when I put this on a graph, I want to use an open circle because I have a value that is strictly less than 1. So again, I'm only choosing values to the left of positive 1. For this second function, my values are strictly greater than or equal to 1. So the first x that I'm going to put here is positive 1, and I'm going to put a closed circle next to it so that I remember to use a closed circle when I graph this on my graph. Notice that the x values I'm choosing are all bigger than positive 1 because that's what my domain restriction states. Here, I'm going to start evaluating these functions at their given x values. So I'm just doing this in my head. Negative 4 minus 2 is negative 6, and then I'll get negative 5, negative 4, negative 3, negative 2, and negative 1. I could use that same process for this second function, but I want to see what this looks like. At this point in Algebra 2, we haven't learned about quadratics yet, so I want to take a look at what this graph is going to look like once it's plotted on a coordinate plane. Notice how it has this U shape. We'll learn eventually that this is called a parabola. Now, this whole graph is not going to be shown. It's only going to be from 1 and x values larger than that. So I'm going to go ahead and click Table, and then I can copy the y values from my table directly on to my t-table on my paper. Notice that those y values get very big very fast. I'm not going to write all of them on my coordinate plane, but I'll go ahead and write them on the t-table just so we know where that graph is headed. Now we'll go ahead and plot these points on our graph. Remember that this point at 1, negative 1 has an open circle, so I need to see that open circle on your graph. I'm going to also plot the rest of these points as regular points, regular dots on my graph, and then I'll connect the points. Watch how I connect the points to the open circle. I just connect it right to the edge of that open circle. This next part's going to look really yucky with all this whiteout, but I made a mistake, so I had to re-record. So the first point that I'm graphing is this 1, negative 3, and I'm using that closed circle. Then I'll go ahead and graph the rest of the points. Remember that this was a big parabola. It was a big U shape. So this isn't going to be a straight line from this point. I'm going to pretend like I'm drawing this curve, but I'm starting at that 1, negative 3. So notice how my graph looks a little curved here. Let's go ahead and talk about domain and range. Remember that domain we're reading from left to right. So as we start on the left side, we notice that that arrow is pointing to negative infinity, writing over the top of my mistake. How fun. Then as we go towards the right, we do have that open gap there, but it's taken over by this curve. Every x value is accounted for. So this graph heads towards positive infinity to the right. The range is very similar as we come up from the bottom and go to the top. That first y value that we see is negative infinity. And even though there's a gap in that first graph, the second graph makes up for it. So we have all y values from negative infinity to positive infinity here. Okay, so right now I want you to try to just do your t-tables for both of these functions. Remember to take a look at your domain restrictions and use those to help you pick your x values for your t-table. Pause the video here, try to do the t-table, and come back when you're done. Both of these were lines, and you could definitely just plug in each individual x value, but notice that you can also put this in on your graphing calculator and copy the t-table as well, just like we did for the absolute value functions. Check your t-table. Notice that you have open circles for both values at +1. So when I put this on a graph, I'm definitely going to put an open circle at 1, 0, and then I'll go ahead and follow that line to the left at -1, 4, and -2, 6, and so on. For this next function, I also had an x value at 1 that was not included, so I am using that open circle again, and then I'm just going to plot the rest of the points like I would normally. So let's look at domain and range. When we're reading domain, we read from left to right. The first value we get to on the left is this arrow pointing to the left, so that starts at -infinity. And as we make our way to the right, notice that we have this break in this graph. We have open circles at 1 for both functions. So I have to signify that on my domain with a 1 and a parentheses because that value is not included. And then I can start up again with the other function at 1 and head all the way to +infinity. That U in the middle is called a union. Just like there's a break in our actual graph, there's going to be a break in our domain here. Remember, to analyze our range, we want to read our graph from bottom to top. So as I come from the bottom, the first y value that I get to is -1. Because that value at -1 has an open circle, I'm going to use a parentheses and start my graph at -1. Then as we keep going farther up the graph, we notice that all of the y values are included until +infinity. All right, so try to do this one on your own. Remember to start with your t-tables and put a mark next to those domain restrictions, whether you have a closed circle, an open circle. Plot your points on the graph, connect the dots, and describe your domain and range using interval notation. Pause the video here, try it out, and I'll come back piece by piece to explain what I did. There are so many other methods that you could use to graph these. I just find that the t-table is the easiest. I do have 1 decimal on my y values here because I do need to show that value. But then I just skipped the decimals on my t-table and only used the whole numbers. It'll give me a nice, clean, perfect graph. So again, I do need to show that -1, -2.5 on my coordinate plane because it is part of my domain restriction. So I can't avoid that decimal. Notice how I guess about halfway between -2 and -3 to plot that closed circle at -1, -2.5. And now I'll just go ahead and plot the rest of those points. Don't forget to connect your dots and notice that the arrow is only on the left side of this graph because the graph doesn't exist to the right. As I start to plot my points for my second function, notice that I'm using that open circle at -1, +2, and I'll do the same here. I'll connect my points and the arrow will only go towards the right. As always, we read our domain from left to right, just like we're reading a book. As we come from the left, the first value that we get to is that arrow pointing to the left towards -infinity. And as we go towards the right, we do have a break in this graph. But as you can see, the graph does continue with all of the x values to the right. So we will end our domain at +infinity. The range here is going to be significantly different than the domain because we do see a huge gap in our y values. So as we come up from the bottom, the first y value that we get to is that arrow pointing down forever to -infinity. And that last y value that we get to in this first piece of the graph is at that point -1, -2.5. Let's all ignore the fact that I wrote +2.5 here. That should be a -2.5, our last y value in that section. Just write -2.5 on your own paper. When I was doing this, I was multitasking like a boss, trying to record this so I didn't have to work on the weekend. So notice that we do use a bracket for that -2.5 in the range. As we're coming up towards that top half of the graph, we do see that that y value is at 2 and it's got an open circle, so we're using a parentheses. And then that does continue on to positive infinity. Remember, write negative 2.5. Our last example today is going to have 3 separate pieces of our piecewise function. When we look at this middle one, remember that that means x is between -1 and +1. So here I'm going to put all of my restrictions on my t-tables first. So I'll start off with the -1 for this f of x equals -2, and I'll use that open circle next to -1 to remind myself that that less than means I'll use an open circle on my coordinate plane. Then for these values between -1 and +1, notice how the -1 has a less than or equal to symbol next to it, so that'll have a closed circle. And then the +1 has a strictly less than, so we will use an open circle for that +1. Then for this last piece of our piecewise function, we're using x is greater than or equal to +1. So I'll put a +1 on my t-table, and I will use a closed circle because of the greater than or equal to. Now I'm just going to go ahead and fill in the rest of those x values into the t-tables. As you can see, I'm choosing values to the left of -1. I had already put the 0 between -1 and +1, and then I'll just choose 2, 3, and 4. This concept is something that we struggled with when we reviewed about lines. This y equals -2 is a horizontal line at y equals -2. So all of those y values on that t-table are -2. If you forget what y equals -2 looks like, put it into your graphing calculator. And when you put this on a graph, you can see that it is just a horizontal line. All of those y values are going to be equal to -2. So if I look at the table here, I'm going to notice that all of my y values on that t-table are just -2. So even though we haven't learned about parabolas yet, we can still plug in these x values. -1 to the second power is +1, 0 to the second power is 0, 1 to the second power is 1. We'll worry about what that looks like when we start to graph. And in this last one, I can also do this t-table by hand. 1 + 1 is 2, 2 + 1 is 3, 3 + 1 is 4, and so on. So I'm going to go ahead and start putting this on a graph. For this first t-table, remember that this was a horizontal line. So first I'll start my open circle at -1, -2, but to the left of that, all of those points are included. So I'm just using regular points on a graph. I could keep going if I wanted to, and I'm going to draw that arrow pointing to the left. As we saw in our first example, these x squared functions, these quadratic functions, look like u's. They look like parabolas. So as I plot this first point, -1, 1, then 0, 0, and then the open circle at +1, 1, it looks like a V shape, but if you plug this into your graphing calculator, you'll notice that it is a U. So notice how I'm connecting these points with a curve and not exactly straight lines. This last piece is just linear, so we'll begin the function at 1, 2, and we'll use a closed circle, and then I'll just plot the rest of my points and connect them with an arrow pointing towards the right. Lastly, to finish up this example, we'll talk about domain and range. When we read domain, we read from left to right. Notice how as we're starting on the left, that arrow is pointing towards -infinity, and as we come towards the right, we see that that point at -1 is filled, that point at +1 is filled, and then we continue on to positive infinity. So our domain is all real numbers here. The range is a little tricky here. So remember, we still read this from bottom to top, and the first y value that we get to is -2. Although there is an open circle at one value of -2, there are real values at -2 that are included in this function. So I'm just going to leave -2 in its own set of brackets by itself as a y value as part of the range. Now I'll include a union symbol to signify that there's more to the range, and that first y value that we get to in the second piece is 0, and then it ends at +1. It is included on one side of that function, so I will use a bracket for that 1. I'll put another union, and that +1 skips up to +2 and has a bracket because that point is included. Then the y values continue up and up forever to infinity and beyond. Have a wonderful day. Thanks for coming. We'll see you next time.